Ionic bonding. Some elements achieve stable electron configuration through the transfer of electrons between atoms. This is our picture.
So what are we seeing in the picture?
We're seeing the one of the electrons getting transferred over here
To who?
to the other element.
Chlorine. Okay, quiet down. Let Danny finish up.
Ionic bond is the force that holds
Cations,
ions
anions.
together. Form when electrons are transferred from one atom to another.
Perfect. When the electrons are transferred from one atom to another, it's when they gain or lose electrons, and usually they get a charge from that. Also, covalent bonds.
It says a chemical bond in which two atoms share a pair of valence electrons. A hydrogen atom has one electron. Two hydrogen atoms can achieve a stable electron configuration by sharing their electrons and forming covalent bond.
Very good. So this picture right here, it shows them doing what?
Oh, sharing electrons.
Very good. Thank you. Molecules.
Alright, so a molecule is a neutral group of atoms that are joined together by one or more covalent bond. The hydrogen molecule is neutral because it contains two protons. Many non-metal elements exist as diatomic molecules.
So what's it showing again?
It's the different models for molecules. Like this one is the electron dot model.
Okay, electron dot diagram, and then this one is just showing a single bond between two hydrogen atoms. Hold on. Tell us about polar covalent bonds.
When an atom formed a polar covalent bond, the atom with the greater attraction for electrons. A covalent bond is which elements are not shared equally is called polar covalent bond. The type of atom and molecule and shape is the factors that determine whether it's polar or non-polar, which are hydrogen chloride atom. Okay.
So it says the electrons spend less time near the hydrogen atom, so this would be a polar covalent bond, okay? Because they do not share the electrons. Polar covalent bonds.
The type of atom and molecule and its shape are factors that determine whether the molecule is polar or non-polar. The oxygen side of the molecule has particles, negative oxygen atom. And then you got Benito's ugly picture right there.
All right, unfortunately, this is a non-polar. Water would be an example of a polar. So in this one, even though oxygen is more electronegative, because they are put in a straight line, the negative charge is spread evenly, and so that is a non-polar covalent bond. Between molecules.
Attractions between polar molecules are stronger than attractions between non-polar molecules. In a molecular compound, there are forces of an attraction between molecules. These attractions are not as strong as ionic or Sultan bonds. They are strong enough to hold molecules together in a liquid or solid.
So what is this molecule right here? Do you know what that is?
An attraction between a hydrogen atom and an oxygen atom.
All right, this is water, yup. And so here's the oxygen atom. It's partially negative, and it's attracted to the partial positive charge of a hydrogen atom on another water molecule. All right, tell me about ionic bonding.
Some elements achieve stable electron configurations through the transfer of electrons between atoms. Particles with a negative charge affect particles with a positive charge.
So explain this picture right here. Sodium,
Sodium is giving
an
electron to
chlorine.
chlorine.
And so what charge does sodium now have?
Sodium now has a positive charge.
And chlorine?
It has a negative charge.
All right, because it took an electron. Good job. Jay, tell me about covalent bonds.
It's a chemical bond in which two atoms, one pair of valence electrons. And when two atoms share one pair of electrons, the bond is called a single bond. And it has 5 valence electrons.
All right, so nitrogen has 5 valence electrons, and then they would share to make a double bond. What about hydrogen? How many valence electrons does hydrogen have?
5. 2.
Okay, this hydrogen has how many? They're sharing, remember? This hydrogen has how many? 1, and this hydrogen has how many?
1.
So when they share, they now have
2.
And what kind of bond do they make?
1.
Single bond. Very good. Molecules.
The attractions between the shared electrons and the protons in each nucleus hold the atoms together in a
Covalent.
covalent bond. Many non-metal elements
Exist as
exist as
diatomic.
diatomic molecules. The element hydrogen has the chemical formula H2. The subscript 2 indicates that there are 2 atoms in a molecule of hydrogen.
What about this molecule of fluorine? How many atoms are there of fluorine?
Dose.
2. And so here's the picture of 2 molecules of fluorine bonded to each other. Or, yeah, 2 atoms making 1 molecule of fluorine. Good job. Tell me about polar covalent bonds.
In a molecules of an element, the atoms that form covalent bonds have the same ability to attract an electron. A polar covalent bond, a covalent bond in which electrons are not shared equally. When atoms form a polar covalent bond, the atoms with the greater attraction from electrons has a partial negative charge. The other atom has a partial positive charge.
So which one attracts the electrons better, chlorine or hydrogen? What do you think?
Chlorine,
Chlorine. So it holds the electrons longer. So what's the charge of chlorine?
negative,
What's the charge of hydrogen?
positive.
Very good. Lewis, tell me about nonpolar covalent bonds.
A nonpolar covalent bond is the type of atom in a molecule in its shape or factors that determine whether the molecule is polar or nonpolar. The poles cancel out and the molecules a whole is a nonpolar. If a molecule has more than 2 atoms, it might be nonpolar.
All right, so CO2 right here. All right, the oxygens hold the electrons a little bit longer, but because it's a straight line, it becomes nonpolar. The whole molecule is spread out. So that is an example of a nonpolar molecule. Tell me about the attraction between polar molecules.
Attraction between polar molecules are stronger than attraction between nonpolar molecules. When atoms form a polar covalent bond, the atom with the greater attraction from electrons has a partial negative charge. The other atom has a partial positive charge. And the type of atoms in a molecule and its shapes are factors that determine whether a molecule is a polar or nonpolar.
So what's happening in the picture right here?
The positive
Hydrogen.
hydrogen is attracted to the negative oxygen.
Very good. And so water molecules are polar. Very good. Thank you.